My name is Carl Anthony, and I work in the automotive industry in Detroit. Sometimes that work encompasses future vehicle technology, and that's what we talk about here, for the most part anyway. This is AutoVision News Radio. As part of Reuters Events Automotive USA 2023, LeddarTech hosted a ride and drive demonstration for attendees. As part of the ride and drive, LeddarTech was showcasing its LeddarVision family of solutions. Attendees were able to ride in LeddarTech's SUV for a short trip around downtown Detroit and learn more about LeddarVision Front and LeddarVision Surround. I was thrilled to have the opportunity to experience this ride and drive with LeddarTech. Afterwards, I was able to sit and talk with Pierre Olivier, LeddarTech's Chief Technology Officer. Pierre helped me understand more of what I was seeing on the ride and drive and helped me get my mind around the idea of something called low-level sensor fusion. By way of introduction, Pierre is recognized for his technical expertise and his decades of experience in the development of high-end products that are innovative, robust, and practical. As an electrical engineer and sought-after speaker and panelist, Pierre is often featured on the agendas of automotive technology conferences throughout North America and Europe. I'm pleased to share my interview now with Pierre during Reuters Events Automotive USA 2023.
Moving at the speed of mobility, this is AutoVision News Radio with Carl Anthony in Detroit, Michigan.
So LeddarTech, well actually first of all we've been in business for quite a long time. The company was started in 2007 and today we're focusing exclusively on software for perception and fusion software for ADAS and autonomous driving. Today we're almost 200 employees. The company was founded in Quebec City, so we still have sizable engineering in Quebec, Montreal, but also we have a significant R&D presence in Israel. So we're trying to take the best talent worldwide to really solve this unique problem.
Sure. Your banner here at the Reuters event, Reuters Automotive USA 2023, behind us, it says solving critical sensing, fusion, and perception challenges. Expand on that a little bit more for us, Pierre.
Okay. Well, actually, one of the biggest unsolved challenges still in autonomous driving is how you achieve a level of performance with manageable cost. So of course we've all seen the robo-taxis with 20, 30 sensors around the vehicle, and these are very, very costly solutions, both from sensor set standpoint, but also from all the computing that's required to process these different sensors. Sure. So in our opinion, that doesn't scale to production cars. So certainly the biggest challenge with production cars is how you get to a price point that customer can manage. So which means lesser sensors, but lesser number of sensors, but also lesser performance from individual sensors and manageable computing platform. The other one is how you make this into a platform, so you don't have to do redesign from the ground up for every single car platform, every single mid-series model change and so on. So really this is where our contribution is making sure that we can deliver with limited amount of engineering the specific configuration that addresses the customer application.
How did you see that trend, Pierre? What was it in the market that led you to make that decision and go that way as a company?
That's a great question. And actually, if you go back a couple of years ago, certainly many of the OEMs were working on the assumption that they would be able to start from level 5, level 4, the robo-taxi platforms, and scale that down to retail autonomy. And that's not happening because it's a completely different way to address a problem. So what we decided was to build a platform that was designed from ground up for these retail autonomy, the privately owned vehicle application, and that would be really optimized for that. Of course, it can do also the higher levels of automation, but we believe it's much easier to scale up than to scale down.
Sure, absolutely. You have a demo vehicle here as part of Reuters Automotive USA 2023. We just got back from a drive. Let's start with the exterior of that vehicle. Tell us about some of the components and some of the sensors that are there on the exterior.
Absolutely. So you've seen this is what we call our LVS, or LeddarVision Surround platform. What you've seen is we have one front sector camera that covers for example, AEB type applications, but we also have 4 cameras that cover the complete 360 degrees around the vehicle. So 2 on the mirrors, and then 1 in the front and 1 in the back. And we also have 4 corner radars that cover also the complete vehicle. And from there, of course, our low-level fusion platform takes all the data from these different sensors and it combines it into a unique model. So, and you've seen we show this as a bird eye representation, but this is really combining both the radar data and the camera data into what we call the environmental model. And that's a very important aspect, because what we're doing is what we call low-level fusion. So we're taking for example, every radar detection, every camera pixel, and we're combining them into this model. And that's key to achieving both the performance in different, for example, harsh weather conditions, the different, of course, difficult lighting, nighttime conditions, and from there, then we perform the object detection, lane detection on this combined model. So that's a very unique, very novel way to achieve it. And that's why we're able, with limited number of sensors, to demonstrate the level of performance that you've seen on the road today.
To that point, we did take a trip around downtown Detroit, outside of the Huntington Place, went past some Detroit landmarks like Ford Field and Tiger Stadium. We were inside the vehicle, in the back seat. Pierre, walk us through what we were seeing on some of the screens with the different lanes and the colors there and the changing colors of the bounding boxes. Walk us through what was happening on the screens.
Absolutely. So first of all, you had the individual displays from the individual cameras. And on this, what we did is we overlaid the detection. So for example, the 3D bounding boxes corresponding to the different dynamic objects around, well, we call them objects, but like, for example, pedestrians, cars, and so on around the vehicle. So each of them you saw a 3D bounding box with the size, but also the heading and the speed of these objects. So that's one of the outputs that we provide, but you also saw the lane detections, where we identify the ego lane, so the lane we drive in, as well as the lanes, the other lanes on the road, painted in different colors, as well as then you were able to see what we call closest in path vehicle. So for example, for AEB application, this is the vehicle you'd want to brake if they started decelerating. So these are the types of objects that we provide to customers. So to us, the customer is typically, it can be either a tier 1 or an OEM, but then they would take these inputs, and from there they would do the specific application, which could be, for example, an AEB ADAS application, or it could be convenience application like a lane keeping, or even like higher, like a highway pilot type application. So we provide and we tailor these different outputs to the specific customer application.
Sure. Pierre, I want to go back to something you said a second ago about low-level fusion. I want to make sure I'm understanding it correctly. So when we say low-level fusion, talking about camera and radar, that's the camera and the radar communicating with each other. Am I understanding that? How would you describe that?
Okay. Well, let me start with what the classical way of doing sensor fusion is.
Yes,
which
please.
Normally each sensor would have its own built-in smarts. So for example, each radar would extract object detections and would send those over, for example, the CAN bus, and then they would be combined by some central computing. But the issue with doing that is, as each of these individual sensors computes the object data, it also, of course, if the conditions are not optimal, there's only so much it can do. For example, in dark lighting, the camera may not be able to pick up car with very high level of accuracy. So if you let the camera then take the decision by itself, you get very limited performance in these specific conditions. So your only way that you can address that is add more sensors and add better sensors. With the low-level fusion, what we're doing is we're taking for example, for a camera, we're taking the image data, and for radar, we're taking what we call the radar detection image, which is each individual echo, but we're not letting the radar decide what if these correspond to an object, and then we're fusing those into a model. So taking, for example, contrast info in the camera, taking these individual radar reflections, and we're merging them into a combined image. So this image has both the 2D data, of course, from the cameras, but also the 3D data from the radar, or it could be LiDAR in a higher level of automation. So that's what we call low-level fusion, because we're taking the low-level output from the sensors and we're combining them into this model. You may also have heard some people refer to this as AI fusion,
sure.
But this is the same principle.
Pierre, how did your engineering team come up with this idea of low-level fusion creatively and intuitively? How did you think of this? And then further to that, how did you apply it and actually make it work in the real world? I'm so fascinated by this.
That's a great question. And certainly this was a problem or a way to tackle the problem that we identified very early on. And if you go back even a couple of years ago, in academia, there was an appreciation that this type of technology could lead to better performance, but there was also a impression that it was very difficult to get to that level because it requires, for example, of course, the different sensors to be very accurately calibrated with one another. So some of the things we did, of course, we developed and we patented some of these base algorithms, but also, for example, the calibration and all that's needed to reapply this low-level fusion in the real world. And that's the biggest challenge.
Sure. In addition to automotive, it's here on your banner at Reuters Automotive USA 2023, but you have a huge dump truck, a tractor, so applications in other industries, agriculture, mining, construction. Let's talk about LeddarTech outside of the automotive industry.
Yeah, so certainly, as I was mentioning earlier, our primary focus today is the privately owned passenger car. But this technology, for the same reason, it helps address some of the challenges of passenger car, which is how you get to performance in the harsh weather conditions. This also means that it's really solves the challenges of some of these off-road environments. For example, mining, where you may have lots of like dust. Or also not very regular and predictable like road surface.
Sure.
This is where the low-level fusion can also help reach the necessary level of performance.
Right. Going forward for LeddarTech, what is on the horizon? What goals do you have going forward, maybe in 2024 and beyond? What are some of the things you're looking at for the future?
Well, a great question, and certainly to us, the goal is to make this into a ubiquitous platform. So this means we're working with a number of OEMs, number of tier ones, in getting these into production vehicles. So that's next, basically our next couple of years are implementing this into series production programs.
Pierre, last question here, but always an important one. Something that I like to ask all my guests, but for you personally, what is the legacy that you would like to leave at the end of your career working in ADAS and working on these very complex but important problems? What's the legacy you would like to leave?
Well, legacy is we're trying to help make this transition from legacy mobility into this new world of basically addressing not only the safety challenges, but also the different societal challenges, how you get, like for example, elderly people to be mobile, how you get the people in cities to be more mobile, and so on. So really what I'd like to be able to say is I've contributed and we've contributed to making transportation better and safer for everyone.
To learn more about low-level sensor fusion and LeddarTech, see the link in the show notes. AutoVision News Radio is available on Spotify, Apple Podcasts, Podbean, and more. From the Huntington Place in downtown Detroit, alongside Pierre Olivier for Reuters Events Automotive USA 2023, I'm Carl Anthony, AutoVision News Radio.